Okay, so this video is explaining how to process data in an Ohm's law lab. Right, so we have two different people did the experiment, right? So I'm going to have two results tables initially. I'm putting the thing that's measured slash the units. Then one person did 1.72, 2.42, 3.47, 4.18, 5.27, and 5.99, and they got 0.028, 0.034, 0.042, 0.047, 0.054, 0.058, and then the other person did the same thing here but with different numbers: 1.68, 2.36, 3.41, 4.12, 5.18, 5.89. So you would think, I'm assuming that all of these were when you put the voltmeter on 2 volts, 4 volts, no, probably 1 volt, 2 volt, 3 volt, 4 volt, 5 volt, 6 volt. That's what you put on the voltmeter, on the power supply, and then when you connected a voltmeter over the bulb, these are the readings you got, yeah? So you might say, okay, well, this is essentially, this set of data here, this column, is a repeat, yeah? Because the power supply was set to the same thing. But because the voltage was different here and here, I don't think we can say that they are repeats. A repeat would have to be the voltage was 1.68 and we had a current 1, 2, 3. Yeah? Well, ideally 4, 5 for the diploma program. Yeah? So I don't think we can call it a repeat. So we actually need to kind of merge this information together into one big results table. So actually, I'm going to cut and paste this. Then I'm going to put 1.68. Oh. And then that's 0.027 from the other person. And I'm going to cut and paste this. And then 2.36, which was 0.032. I'm going to cut and paste that. That was 3.41, and that was 0.0412 was what the person wrote down. But we need to be clear, each of these has been 2 significant figures. So this must be 2 significant figures, so delete the 2, yeah? Or round it if it needed rounding, whatever. In that scenario it didn't need rounding, did it? What's next? 4.12, 0.046. Having done some research into filament lamps, why would the second person consistently have lower voltage than the first person? So if it was a battery or a cell that was supplying the power to the circuit, I would agree with you, yes, that's what's happened. What is most likely to have happened is that the bulb was hotter for one of the 2 people, and that has led to a higher resistance and therefore different voltage and current readings. I would say that the first person to have done the results had the hotter light bulb for whatever reason. Potentially they were setting it up so it's been on a little bit more than the second person who came later.
So the hotter more resistance?
Hot light bulbs, yeah, high resistance. because if you imagine the atoms inside, they're vibrating, which makes it harder for the electrons to pass through. If you've ever seen that show Wipeout, you ever seen that? It's amazing. They had one in Abu Dhabi a few years ago. I tried to do it, but they wouldn't let me. Something about age. Yeah, people try and climb through assault courses. There we go. So these are our results. Annoyingly, we would fail the diploma program, well, not fail, but in the strand of the diploma program where it says in IA, sufficient and relevant raw data. Our raw data is relevant, but we do not have sufficient. We have effectively 12 increments, which is amazing, but we do not have 5 repeats of each one. So we have insufficient data. If you set up your circuit with a rheostat, a variable resistor, you can adjust it so that the resistance, the voltage across the light bulb is exactly the same every time. That would just keep adjust. Yeah. I would do them all, then go back, and do them all, and go back. That's how I would repeat it. So here's our data. There's actually no processing to be done here, is there? Our results table is insufficient. Although it has the units, it does not have uncertainty. So I would like to see an uncertainty in there. I'm assuming plus minus 0.01.
The R-square is actually 0.99, so it's actually pretty close.
Yeah, it probably is going to be really good. Now, hang on. No, yeah, that was right. That one was wrong. Should be 2 zeros after the decimal point, shouldn't there? No, 1 0. Yeah, that's right. Because in this one, it could be 1.69, it could be 1.67. So it's, yeah, plus minus 0.01. Yeah. Great. Then to graph it, just select the data that you're going to graph, not the headings. Select the data, go to Insert, a graph, XY scatter, and there we have it. Then you click on the graph in the empty space and you go Add Chart Element. You want the titles labelled. With numbers, you want the titles on them. You want a chart title. You want, don't need data labels. We are going to put some error bars on them. So I just put standard for now, and then we'll play about with everything. You could put more grid lines on if you wanted to, but I don't feel like it's necessary. I don't think you need a legend because there's not anything going on. You need a trend line, which is not exponential. Legend, if you had a graph with lots of lines on it, all the lines would be different colours. So if you did 5 different light bulbs, you could plot them all on graphs. But I think we want a squared polynomial. Yes. Yeah, you want a polynomial thing, and it's because it should be a curved line, which should make it an x squared, I think. But is it logarithmic? Could be logarithmic actually. Yeah. What we'll do is we'll make the error bars correct,
So I don't know,
and then
linear exponential.
we want a curved line going up, right? We do want it to go through the y-intercept. Oh, it doesn't let you on that. What about polynomial? Will that let you? Yeah. Want it going through the 0, 0. We're also going to forecast it backwards by whatever the first value is. So the first value is 1.68. So if you forecast it backwards 1.68, it will go to the y-intercept there, or even maybe better 6.7, and it doesn't squeeze the display equation, display r squared. Then we want the error bars, so I'd try and click on your error bars. There we go. Fixed value of 0, 1. Oh no, yeah. But this, oh, that's horizontal. Horizontal is what have we got on the x-axis? We've got voltage on the x-axis, so that is 0.01. Then we want to click on the verticals, and then we can do fixed value 0.001. There we go. Oof, that can't be right. How's that? How's that done that? Or maybe I have to click somewhere else for it to then register it. Yeah, there we go. You have to click somewhere else for it to then register it. Yeah, the error bars are now tiny because our error in this is pretty minimal.
So how do you add the error?
Go on to add chart element top left, error bars, and then I just put standard, and then clicked on those error bars, and you're able to adjust the value of them.
Yeah, but for me the fixed value, like I can't change.
I think the trend line that we've got should be logarithmic. That looks better, doesn't it? And I'm not going to forecast it backwards quite so much. It's gone underneath it. There we go. Yeah, that's better. And the r squared has improved, which means it's a better match. Yeah?
So linear is a 0.99.
Hmm? Yeah, but it shouldn't be a linear pattern.
So I can't change the values for my error bar.
You can. You click on the actual error bar, and then it should bring up at the right of the screen when you click on it. It's really hard for me because the errors are so small.
Yeah, but so, look, the like grayed out, I can't click the fixed value thing, I can't enter a number. Click on the so what's the fixed value?
So this is our graph.
So what's the fixed value?
So the fixed value of the errors on the x-axis is the voltage, isn't it? Is the x-axis. So 0.01. And there we have our graph. Now, ideally, we would have a raw data table followed by a process data table. But as I said, we don't have any data processing to do, so we don't have a process data table. It's literally the same thing. But that's another example as to why this